Welcome back to educator.com and our series on Java. Today we're going to talk about classes, objects, and methods. We're going to get a little deeper into classes, objects, and methods right now and what these are, and then we're going to see them in action in some code later on. First of all, with classes, objects, and methods, I like to compare these conceptually to parts of speech. So we're all pretty familiar with how we speak, parts of sentences, what words are, nouns, verbs, so forth. So just to get your mind around what Java is and some of these terms, let's compare them to some words. So in general, class, you might think of that as like a general noun or as opposed to a proper noun. So you might think of this as a bird or a ship, for example. If we get more specific, an object within that class might be a specific kind of bird, in other words, an eagle, or a specific kind of ship, an aircraft carrier. So we identify things as objects within their class. Then when it comes to something like a modifier or a descriptor, like an adjective, in Java they usually call those attributes. And you might say part of the eagle are the wings, or part of the aircraft carrier is the flight deck. So that's part of the object. Then we want to know, what does that object do, or what can it do? Then we need these methods. A method is like a verb, the action that the class takes, or the action that the object takes, or what it does, or what task it performs, or what we want it to do within the program. These methods will often have parameters, which we call arguments. And arguments are the parameters of the method. So if we say that the eagle, for example, can fly, we might want to know how fast or how high. Same thing with an aircraft carrier, with a ship. How fast is it moving? What direction is it moving? Things like that are arguments when it comes to methods. Now, as we set up variables in our program, some of these variables will be objects within our class. And as that object is created, and as that variable is assigned a value to it, whether it's text or a string or numbers or what have you, that object then becomes an instance variable. And an object's specific existence within the program, that's what we call an instance of that object that's created and then stored in your system's memory as the program is running. That little memory block is saved and reserved for holding that particular instance of that object. And then one of the great things about Java is garbage collection, as they call it, as those things are automatically, and that memory is automatically removed when the object isn't needed anymore, and that memory is freed up so that other parts of the program, if needed, can use it. Now, as a program is running, some methods that will be called and run are what we call set and get methods. And what these do, we'll see these in action when we look at our programs today. These are methods that can set a value for a variable or an instance variable. So we might say, let's set that amount to $50. Let's set that word value for the particular name of something as like we said earlier, a ship, an aircraft carrier. We set that text or set that number value. Then when we want to retrieve those values, we use the get method. So we might say, set the value to 100, set the amount value to 100, and then later on in the program we say, get that amount value so that we can see it, or so that we can multiply it, we can add to it, we can subtract to it, and so on. Now, a lot of these set and get methods and all objects, especially with numbers and text, are going to be falling into two main types of data type categories. We've got primitive types and we've got reference types. Primitive types, these are the basic building blocks of data. Boolean, yes, no, 1, 0 fields, a byte, 8 bits, a character, any of the ASCII, standard Unicode or ASCII characters, keyboard characters, letter A, number 1, punctuation marks, so forth. And then we get into numbers. And short, int for integer, long, float, and double are all number types. And you can think of these as a short number And they all depend on how many bits of memory they require and what is the minimum and maximum value that can be stored with one of these primitive data types. A short integer uses 16 bits of memory, and it can be plus or minus 32,000, roughly 32,000. So that sounds like a lot, but it can't handle numbers over that or under that. So it can't handle any number over 32,000 some odd digits, or numbers I should say. So then we might have to go to a true integer, which uses 32 bits of memory, and that can go up to about 2.1 million. Now, these are all integers so far. We can't have any decimal places yet. We'll get to that in a second. A long integer takes the most amount of memory, 64 bits, so that would be 8 bytes of memory, and it can go up to plus or minus about 9 quintillion. So that's quite a large number. So you don't need a number that large with that many digits very often. Most of the time you're going to stick with the most common type of integer is just a regular int integer. Now, if you need decimal places and you need fractions, then you're going to have to use a float or a double. Now, when they say float, they mean the floating decimal point. So in other words, it's just like an integer. It can go plus or minus 2.1 million different numbers, but where that decimal point is placed within that number is why they call it a float. It can handle a floating decimal place. So it could be something like 1.2345, or it could be 12345.6. It doesn't matter where that decimal place occurs, but the number of digits and the number of total numbers it can store is still finite. And then double is just, they call it double because it's double the size of a floating point number. A floating point number is 32 bits. A double is 64 bits. So it can go, handle a lot more digits. It just takes up more memory. Now, on the other hand, reference types here, that's pretty simple to explain. That is everything else. So if it's not a primitive type in Java, it's going to be a reference data type, and that's all other classes, all other objects, variables that you create and name and call then in your program, and they are local to your program, and they can be used within that program, and it can be any data type you want. All right, when an object is initialized, in other words, when you first name, declare, and then build that object, it uses a constructor statement. We'll see some examples of constructor statements as we go here. And then that constructor, in parentheses after you name it, you can use that area to specify attributes if you need to get more specific. If no attributes exist, then a default constructor, Java uses a default constructor, and if no default constructor is used, or I should say if the default constructor is used, that default, and you don't apply any specific parameters or attributes to it, then it'll have a default value, and that default value will usually be 0 if it's a number data type, it will be null if it's a text or a text string data type, or it will be false or 0 if it's a Boolean type. All right, now let's go and take a look at some of our coding examples. The first thing that we're going to take a look at is a program that calculates squares and cubes of all the numbers between 1 and 10. Now let's run this program first, and then we'll come back here and look at the code to see how it did it. All right, so I have pre-compiled all the programs that we're going to use in these later lessons. So because we already handled the tasks of how to use the javac command to compile and convert your text or .java files into .class files, we won't be going through those steps anymore. I'm just going to assume that we know how to do that, and we're just going to run the programs. So this program, we are going to say Java, and we called this one squares and cubes. And you can see when the program runs, it has 3 columns of data. It lists the number, first of all, and then what that number would be if it was multiplied by itself and then cubed, so to the power of 3. So 0, of course, and then 1 times 1 times 1. 2 times 2 is 4. 4 times 2 is 8, and so on down the line until we get to 10. 10, 100, and 1,000. All right, so let's take a look and see how this is done in the code. All right, in the code here, we start with our public static void main statement. And then we just want to print out something that will function as the header row for the table. So we say system out print if, or print f for format, and then we have our headers number, square, and cube. All right, now we get into our called or our instance variables here. So we set up an integer variable and we call that x. We initialize x as 0. And x is an integer, and then as we use this integer, this variable, these are instances. So down here we've got instances listed in our 10 system out print statements. And so first we say we want to list the number, just plain x. Then we want to list x times itself, and then x cubed. Now, we originally defined x as being 0, right? So it starts out as 0. That's why we get 0 on the first line of our output. Then we say x equals 1. So now we've changed the value of x from 0 to 1. Then we go through the whole printing process. We put we put the number, we put the square, we put the cube. And we do that down the line. Notice we're not using any technical or advanced if technology yet, any if logic yet. We're just doing all of this manually. So every instance has its own line, 4, 5, 6, and all the way down to 10. All right, then we end the program, and then we end the class. So when we run this, because see, that's why we got the output we have. We've got the header row, we've got 0 as it starts out, and then 1, 2, 3, 4, all the way down to 10. All right, let's look at our next example. All right, here we've got a more complex program, and we're going to get introduced to if logic, and then in lesson 4 we're going to take a much closer look at some if statements. But right now we're going to keep it simple. This program sets up a bank account, and so we're going to have a balance, and then we're going to try to create some programs that will add to that balance and subtract from that balance. All right, so the first thing that we do here is set up our public class called account credit. Then we set up a double data type, and we just call that balance. That's an instance variable that stores whatever the balance is going to be of an account. Then we say account credit. We set that as a constructor. We build that, and we call it initial balance. All right, first we're going to validate that initial balance is greater than 0. And then if it is not, the balance will be initialized to the default value of 0. If it's greater than 0, we're going to use that balance. So we say if the initial balance is greater than 0, then the balance will equal the initial balance. And this information is going to come later in the program, or it's going to come from our companion program. This is a special type of Java program that is actually one program is going to call the other. All right, so here's the end constructor. We're done with initiating the balance. Now we're going to add an amount to that account. So we're going to say credit, and then that public void, that statement, that variable we call credit is going to equal the double. Now we're not talking about double as in times 2. We're talking about the data type double. The double, it's going to be the amount. So now credit equals the amount. Now we say balance equals balance plus amount. So whatever amount we're going to add is going to get added to the balance. And now that is going to be the new balance. All right, so that is end of the method that we just named credit. And then we are going to get that balance and then return that balance back to the original call. And then it's going to display the balance. Now let's take a look at the companion program. This is what we call account credit test. And this is actually the program that is going to run, and you're going to see how this program is going to run, and it is going to call that previous class. We call this previous class account credit. Let's see if that shows up in our account credit test. All right, so here we actually have our public static void main statement. Notice that we did not have that in the previous example because it is not the program that gets run initially. Account credit we are going to call account 1, And then we are also going to create another account, account 2. So we're going to have 2 examples of accounts here. So here's where we're calling account credit. Here's the variable, here's the class that we've named in the previous program. We are going to set that account credit for account 1 with an initial balance of 100 here. We're going to set the account 2 with an initial balance of 20. Then we start out with just displaying to the user the original initial balances. So we say system out print the account balance for first account, account 1. Do the same for second account, account 2. All right, now we're going to create the scanner. Notice how we called our utility, imported our Java utility scanner up here because we're going to be taking information from the user. And here we are going to use the scanner to obtain information from the user. So we're going to say system in, and that is going to be the deposit amount. How much do we want to add to the balances? All right, so then we run through this twice. We enter a deposit amount. We ask the user for an amount to be added to account 1. We add, and then we display that amount with both account 1 and account 2. So it'll be the new balance for account 1. Account 2 we haven't changed yet, so it'll be the same. Then we repeat this process for account 2 here. We say enter a deposit amount for account 2. We save the user input in the input next double statement, and we let that equal the deposit amount. And then we say system out, and then we add that. We give the user a message that we're adding that amount to account 1 and 2 in this statement. We did the same thing up here with account 1. And then we add that amount to account 2. Now account 2 credit equals the deposit amount. And then we display, similar to we did after the first account was added to, we display the account amounts. All right, so let's see this in action when we run it through the command prompt. All right, so we are going to say we want to run the Java program, and we call this account credit test. All right, it runs, and the first thing it shows us is the account balances. It says account balance 1, 100, account balance 2, 20. All right, now it says enter deposit amount for account 1. Let's say that we want to add 50. So we say 50.00. I hit enter. It says it's adding 50 to the account 1 balance. Now the account 1 balance is 150, 100 plus 50. The account 2 balance is still 20. Now that time we added 50.00. Let's add just a plain flat integer to account number 2. Let's say that we just want to add $5. Hit enter. It says it's adding 5 to account balance 2, and now account balance 1 is still 150. Account balance 2 has been bumped up to 25. So you can see that it is taking those amounts that we're entering and then running through the program. The first program that I showed you, account 1, let's flip back to that so you can see that again. The account credit, that initializes it, gets the account balance, and then does the math by saying balance plus the amount. The account test program, that is displaying all of our prompts, prompting the user, taking in the information, and then passing those values back to our account credit method, account credit class, I should say. All right, now let's see one variation on this. This is going to do the reverse. This program is not going to add to the totals, it's going to subtract from the totals. So in accountants' terms, that would be the difference between a credit and a debit. Now this is set up and constructed the same way. We just have set it up to subtract from the balances instead of add to them. So here we've got our constructor, initial balance. We do the same thing. If it's greater than 0, we set up that double value, double data type to be the amount. We say the balance is going to be the balance plus the amount. And we add one more wrinkle here. Notice these if statements. We say if the amount is greater than the balance. What happens if somebody tries to withdraw more money than they have in their total, in their account? Then we're going to say if the amount is greater, the amount that we want to withdraw is greater than the balance, then we're going to return the message debit amount exceeded account balance, and it's going to stay the same. So it's not going to subtract. It's going to leave it as it is. If the amount is less than or equal to the balance, then we will say balance equals balance minus the amount. So there's where we subtract the value from the total balance. And that's the end of that class. Now let's look at the accompanying program, the one where we use it to retrieve data from the user. Here we are setting up our scanner because we know that we're going to take in data from the user. We call this class account debit test. We have our main public static void main statement here because this is the program that we're going to run. And we set up our initial values, again with 100 in account 1, 20 in account 2. The lower part of this program is very similar to our credit program. So we display the amounts, we intake the amount that we want to withdraw, enter withdraw amount for account 1, same thing for account 2, and then we return the balances after the amounts have been subtracted, in this case. Same thing for account 2. All right, so let's see this. All right, so let's see this program in action now. At the command prompt, I'll clear the screen, and we are going to run the program Java account debit test now. When we run it, we get our initial balances, 100 in the first account, 20 in the second account. Now it asks, enter the withdrawal amount from account 1. Okay, let's say that we want to take out 75. It subtracts 75 from account balance 1. We end up with 25. Enter withdrawal amount for account 2. All right, I'm just going to enter 5. It withdraws that amount, and we end up with 15. Now, let's run that part of the program where we will test to see what happens if we try to withdraw more than is originally in there. We're going to run the program again. So let me take out that space. All right, so we enter a withdrawal amount for account 1. We've got 100 in there. What happens if I enter 110? First of all, it says subtracting 110 from account balance 1, but then it says debit amount exceeded account balance, and then it returns that we still have $100 in that account. So it caught that error. It won't let us subtract an amount that is greater than the original total. So if I enter 45 for account 2, it says the same thing because we only had 20 in there. So it's a little, catching mechanism so that you cannot make the mistake of trying to withdraw too much and end up with a negative number. All right, now let's look at our last example, and this is a program that is going to be a hardware store inventory system. And here we set up a public class called invoice, and we're going to be able to see how it's going to add to an inventory level, and then it will use prices to calculate how much that inventory is worth. All right, so we set up some variables here. A 4-argument constructor. We say that we want a string called part number. We want one called part description. We want an integer called quantity. And we want a double floating point value called price per item. Then we say that the invoice is going to include all of those things that we just initialized. We're going to say that the part number is going to equal the part description is going to equal description. And first we want to see if there is any inventory that we have identified to begin with. So we say if the count is less or greater than 0, that determines whether an item is in stock. If the price is greater than 0, that validates that we have a positive number entered for the price of the item. And then we say price per item equals price. That is going to assign the value price per item. It's going to assign that valid price value to price per item. Then we're going to set some values. So these are what we were talking about earlier, set methods. So we say we want to set the part number. This part number is going to equal part. And we do the same thing for string get parameter. Then we're going to get that part number, and we're going to return that part number as a value. We do the same things for our other 4 variables. set part description, get part description, return part description. We're going to do the same thing for quantity, set quantity as an integer, and then we verify that it's greater than 0. Then we want to get the quantity number, and then we want to return the quantity number. Same thing with price per item. We set the price per item as what we entered as, or what's been entered as price. We make sure that the price is greater than 0, and then we get that price item, and then we return that price item. And then get invoice amount will calculate. Once we look at our companion program, you'll see how that is going to get displayed. Right here it gets calculated. We say get the get quantity times the get price per item. We multiply those two things together. That is like saying quantity times price. That's going to be the total inventory value for everything that we have in stock. All right, now let's look at the companion program here. This is the main class that we call invoice test, and this is going to call our original program that I just showed you, which is the class we called invoice. So we've got our public static void main statement here, and then we say invoice and invoice1, that is going to equal new invoice, and we set those values as 1, 2, 3, 4. We say that we have hammers in inventory. We say that we have 2 in stock originally, and we say that the price is $14.95. All right, then it's going to return values in our system out statements. Then, in this coding block, we are going to change those values. All right, so we say we want to change and set that part number from 1, 2, 3, 4 to 1, 2, 3, 5. We're going to change the description from a hammer to a roofing hammer, and we change the quantity from 2 to 3 and the value from $14.95 to $19.49. And then we reprint that data using that new information. All right, so we'll see this in action in a second. Then we run through the same process for a new invoice item number. We say 1, 2, 3, 6. That's going to be the paintbrush, and so on. We start out with initially having -5 and -19 or $9.99. We set those values to their new values as 3 and $9.49, and then we display them to the user in this block here. Part number, quantity, and price per item. All right, let's see this in the command prompt. All right, let me clear this screen. And we want to run the Java program invoice test. All right, notice what happens here. We've got the original invoice information. We said the part number for the hammer was 1, 2, 3, 4. Quantity was 2, price was $14.95. 2 times $14.95 would be $29.90. Then it gets updated through our updating statements. Part number is now 1, 2, 3, 5. Quantity is 3, and we've got the new price, and we've got the new price total. Same thing happens with our paintbrush. 1, 2, 3, 6. We have quantity 0 because we said -5. We have price 0, invoice amount 0. When we update those values, we didn't change the part number. We didn't change the description. We did, however, change the quantity, which is coming through, and we did change the price, so we do get the new invoice amount. So you can see that our program is working. It is not only calculating our inventory totals according to what we entered, but then it is updating them and storing the new values and displaying those new values. All right, so in this lesson, we learned a little bit more about what classes are, what objects are within those classes, how to declare them, how to use them, and then how to create methods, especially the get method and the set method, to set the values of these variables and to then get them in their instances. All right, next we will take a closer look at if logic in lesson 4, and thank you for watching educator.com.